The KMP algorithm is a well-known pattern matching algorithm. It is the first string matching algorithm with linear time complexity and is used in various applications of computer science starting from machine learning to compiler designing. In this course, we will discuss the basic naive algorithm along with its drawback which lead to the use of KMP algorithm. The concept and its implementation in Python will also be discussed along with the time complexity of KMP algorithm. So put on your thinking hats and let's get started with this session on KMP algorithm in Python. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
Hello guys, today I'm going to talk about KMP algorithm. So before getting ahead, let me tell you what is the agenda for the session. That is, I'm going to talk about what is pattern matching and then talking about a very basic naive algorithm which follows a brute force approach basically. We'll talk about that and then discussing its disadvantages, we'll move forward to talking about KMP algorithm. So how this KMP algorithm works, how is it better than the naive algorithm, the basic algorithm that is there for pattern matching. And then moving ahead, we'll see the algorithm for a KMP algorithm. And then we'll talk about its implementation in Python. Moving ahead, we'll see the time and space complexity of the KMP algorithm. And then lastly, what is the real-time applications of KMP algorithm will also be discussed. So let's get started. Now, what is pattern matching? As KMP algorithm is one of the algorithms that helps in matching the pattern, so it is important here to understand what is pattern matching. So talking about that, given a set of characters, tokens or any data, if we have to match or find out any pattern into it, any repetitive occurrence of character, tokens and data in the given string of characters or tokens or data, then that is called as your pattern matching. Okay. The match should be exact. If a pattern is given and then you have to match that pattern with the given string, of characters, tokens or data, then the match should be exact. Or if there is a given sequence of characters, tokens and data and you have to find out some token, you have to find out some pattern. That is, you have to analyze the given string and find out a pattern. That is a different thing. That is your analysis of characters and tokens in the string given and find out how the pattern is followed in that. But if a pattern is given to you and you have to find out its occurrence in the given set of characters, tokens and data, then it is called as pattern matching. Okay, and there the match should be exact. In real scenarios, there are so many places where pattern matching is done. If I talk about only the computer science domain also, there are a lot of places where pattern matching is done. For example, first one is the machines make use of pattern matching. If you remember from the concepts of automata theory, that is all about your patterns, right? One state to other state, how the machine transfers, that is, the pattern is studied, right, in the form of zeros and ones. So that is one of the application area for pattern matching. Next, even in the machine learning field, ML field, the features are selected or found out in the given data with the help of pattern matching. Third, various programming languages like Unix, Java, Python, they have expressions concept to find out patterns or to perform pattern matching. Like if you want to look for a certain data in a complete file, then these programming languages provide a programming construct in the form of expressions to perform pattern matching and search for a given set of string into a file. Lastly, there is one more application area when it comes to compilers. So compilers converts a given set of codes into a parse tree. That is called as your parsing. And after that, it performs pattern matching on that as well. So these are the application areas in computer science domain where pattern matching is used. Now let us see the example here. So this is a given string which I'm talking about. Okay. This is a given string of characters. Similarly, the given string can be of tokens of some data, zeros and ones as well. But as of now, this is a string in this example of a characters. And this is a pattern given, A and B. So you have to find out the occurrence of B after A. Single occurrence of A, single occurrence of B. Okay, from the given string. So to find out, you can, right now without applying any algorithm or any process, let's just simply find it out. So you have to scan the string from beginning to end and find out if the same occurrence, that is A followed by B, the single occurrence of A and single occurrence of B is there or not in the string. So you'll start from the beginning. So yes, you can see in the beginning itself A and B occurs there together. Then moving ahead, B and A is there, so it's not A and B. Then C, again B and A is there, then A and B is also there, right? Then again A and B is there. So AB has occurred 3 times in the entire given string. Okay, if I talk about the indexes of it in computer programming terms, so if I mention it from 0, starting from 0, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are the index numbers. So if I tell you what are the index numbers where this pattern was matched, so you have to tell the first index from where the pattern starts. Okay, so AB starts from 0 index. So at 0th index, AB is found in the given string. Then AB here also. So starting index is 8. So at index 8 and then at index 10. This is also matching AB, matching with AB. So at index 10. So 10. So these 3 indexes are there where the pattern AB matches in the given string, right? So this is an example of pattern matching. Now let's move ahead and talk about the algorithm, the process which is followed to match this pattern. Right now, just by looking at the string and just scanning through the characters of the string, we try to find out. But there is a process as well, algorithm as well, which is followed to find out this pattern in the given string. Because string may sometimes be very large. It's not possible to scan the string by our own eyes and then try to find it out, right? So we'll see how and which all algorithms are there for that. Let us now talk about naive algorithm. So before studying KMP algorithm, we have to understand what is the basic algorithm that is followed for pattern matching. And that is called as your fundamental algorithm or basic algorithm or naive algorithm. So let's see how this naive algorithm works. Try to understand this with the help of an example here. So there will be a string given and a pattern given. So you have to match this pattern into the strings, and wherever it matches, that index number will be the output. Okay, that index number will be the result. So this is a pattern given which has certain characters D, B and C. Similarly, there's a string given which has certain characters in sequence. Okay, so in naive algorithm, the logic followed is that you have to compare the characters of the pattern with the characters of the string, starting from the very first character. Okay, so let me make it more explanatory by writing it over here for you. B, A, D, B and C. Now the pattern is D, B and C. Okay, so we'll start matching from the first index. So first index, if I write D, B and C, is it matching? Is D matching with A? No, right? B is matching with B, C is not matching with C, meaning D, B, C is not matching with the first 3. Completely it should match, not just one character or 2 characters, but all the characters which are there in the pattern should match completely with the characters in the string. Here it's not matching. So what you will do, you will move now this to the next position. We started from 0th index. From first position, we'll go to the next one. So D, B and C. Now this D, B, C will be matched with this 3. Is it matching? No, right? D is not matching with the B. B is matching here, but C is also not matching. So definitely this is not matching. So what we'll do, we'll move again this one more character ahead. So D, B and C. So now this time we have to match with these 3. Okay, so is it matching with these? D is matching with B? No, right? It means it is not matching. So what we'll do, we'll again move this one more character ahead. So now it will come from, start from this location, D, B and C, right? Okay, let me erase and write it here so that it's little clear to you people. So if I'll erase it, okay. Now we have to start from here. So D, B and C, is it matching? D is matching with A? No, right? So again now we'll move one more character ahead. It means I'll go from this location TBC to next. We'll start from B now. Okay. So we'll match from here. D, B and C. So is it matching with the characters in the string? DBC? No, right? D is not matching with the B. First character itself is not matching. So we'll move now from this location, right? So I'll move this from that location now. So in that case, now we have to match from here, D, B and C. Is it matching with this? No, right? So we have to move to the next location now. So let me move it to the next location. So next location, if I move, now D, B and C will be over here. So you see, is it matching with the characters in the string? D is matching with D, B is matching with B and C is also matching with C. It means at this location, finally, the characters in the pattern are matching with the characters in the string. It means, yeah, the pattern is found in the given string. And at what location? So if I start counting it from the 0th index here, or if you start counting from first, suppose, so 1, 2, 3, 4, 5, 6, 7, 8. So at the 8th index, we found out the given pattern in the string. Okay, so this is how the basic naive algorithm works. Now, this was a very simple example, okay, where at one given point itself, the pattern was matching with the string. Now, let us see one more example to understand naive algorithm. So again, the same pattern will be followed. So let me write a string here for you. So A, B, B, A, B, A, B, and C. Okay. The pattern to be matched is A, B, A. So we'll start from this A, B, A. Now let me try to trace it with the help of programming concepts. Like how if you have to implement this in programming, how will you implement it? So with that terms, if I try to understand this, so let me change the pen pointer color. So suppose this 2 pointers will be needed, okay? I and J. So I is a pointer which will be referring to the string characters and J is a pointer which will be referring to the characters in the pattern. Okay. Now, what you have to do, start from the first index. J will start from A and I will also start from A. So you have to match I with J. Okay. So you have to compare IN at the ith index, whatever is the character, and at the jth index, whatever is the character, you have to match these two. Fine. So is I and J equal? So yeah, I and J are same, right? They are equal. So in that case, if both are equal, then you have to move both the pointers to the next index. Okay. Now here also they two are same. At the ith index we have B and here also the jth index we have B, right? So what we'll do, we'll move both the pointers ahead. So I hope this is clear here that if the characters at both the pointers are equal, are same, then we have to increment both the pointers to the next character. Okay. Now we came here, I is pointing to B, J is pointing to A. Is I and J both equal here? Ith location we have B, jth location we have A. It is not equal, right? So when it is not equal, then what you have to do? So when it is not equal, so if at the ith location, if the string at ith location is equal to string at jth location, then you have to increment I and J both. Okay. But if string at ith location is not equal to string at jth location, then what you have to do is decrement J to the first position, bring J to the first position, that is the first index. Okay. In programming, we refer it from 0th index, right? In Java program, if I talk about, so 0, 1, 2, 3. So it will come to the initial index, the first index. And where will I come? Where will I be pointing now? I will be pointing to one less than where J is pointing. Meaning, suppose J, either I write J is equal, will be pointing to 0 or to the first index, or if I say J will be incremented to J minus how many steps it has moved ahead. Like J was initially pointing here, right? And it has moved ahead 1 and 2, two locations, one this and this, right? So J will be equal to J minus 2. So right now, if it was pointing at, suppose this third location, 1, 2 and 3 location. So it will go 3 minus 2. It will point to one location. If these are the indexes and j was pointing to 3, so now j will point to 3 minus 2. It will point to the first character. So either j will be pointing to 1, 0, because if you can mention here 0 or 1, anything. If you are counting from 0, it will be 0. If you're counting from 1, it will be 1. Okay. So if I count from 1, so 1, 2, 3, right? So either j will be pointing to j minus 2, that is your 1. And then I will be pointing to 1 less than j. That is, I will be equal to I minus 1. Getting it? So if j was decremented by 2 places, 2 indexes, I will be decremented by 1 place. Okay. If j would have been decremented by 3 places, I would be decremented by 2 places. Getting it? 1 less than how many j was decremented. So you can see here. Now if I erase this and try to explain you. Now, okay. So here, if we see, j was pointing here, right, at A, and I is pointing to B. Now B and A are not same. So we have to do what? Decrement j and I. Decrement where? So j will be decremented to the first location, to the first position again. So j will be now pointing here. Okay. And where will I be pointing? So j was decremented one location, 2 locations back. Right? So I will be only one location back. So I will decrement by only 1. Okay. So it will start from this location for I now. Getting it? Okay. So let me erase this, these parts. Okay. So right now I is pointing here and j is now pointing at the very first location. Right? So j is pointing at the first location. Now what you have to do? Again compare I with j. Is I same as j? No, right? So if it is not same, then what you have to do? Decrement j and I both. But as j is already pointing to the first location, it cannot be decremented further. Then in that case, you will simply increment I. Now I will be pointing at this location. Getting it? So in this condition, if it is not equal, the other condition also you have to check is, and j is not equal to the first location at the first index. Then only this thing you have to do. If j, the other condition is, so these were the 3 conditions. The other condition is that if j is already pointing to the first index, then you don't have to do anything with j. You just have to increment I. Okay. So this is also one condition. So you can see here, I just incremented I, no more decrement of j. So now I is pointing here, j is pointing here. So now compare b and a, I and j, right? So b is equal to a, no, right? If it is not equal now, then what you have to do? As j is already pointing at the first index, you just have to increment I. So I will be incremented here. Now compare I with j. So yeah, I and j are equal, right? So if it is equal, what we should do? Increment both. So yeah, I will be incremented to this location and j will also be incremented to this location. Now I and j will be compared. Is it equal? No, it's not equal. And j is not pointing at the first index also. Then this is the condition which you have to satisfy. That is, you have to decrement j to the beginning of the pattern, right? So j will be pointing here. It is decremented by 1 pointer. So I will be decremented by how many? 0, right? Because as I said, if j is decremented by 1, I will be decremented by 0. So I will be pointing there itself. Okay. So now you'll compare. So right now what the situation is before comparing, j is pointing at the first location. Okay. So we'll write j here. Now start from the beginning. I and j will be compared. So yes, it is matching, I and j. Okay, if it is matching, then you have to increment both I and j. So I will be incremented here. J will also be incremented here. Now compare these two. J and I both are pointing to B character. So yeah, it is equal. So again, we'll increment both. J is incremented and I is also incremented. So yeah, now I and j again both are same, right? And as we have reached to the end of the pattern, if I increment j further, I will not find anything. It will be end of the pattern, right? End of the characters. Hence, this is the pattern found in the given string. Okay, so we will print the index as an output. The starting index for this pattern is an output. So if I count from here, the index is 1, 2, 3, 4, 5. So 5 will be the output for the index number where the given pattern was matched with the characters in the string. Okay. Now, we don't have to stop the algorithm here. The algorithm will go on till we reach to the end of the string. Once we reach to the end of the pattern, the output should be displayed that yeah, the pattern was found in the string at this given index. And then program should continue further, right? So I'll go ahead and now I'll compare, though I will be incremented here. Okay. So now I is right now pointing at B and J will be pointing in the beginning because J has already reached to the end. So now it will come back to the beginning. So J is pointing right now to A. So A and B, that is I is pointing to B. It will be compared. So is it same? No, these are not equal. So if it is not equal and J is pointing to the beginning of the pattern, then only I will be incremented. Okay, so I and J again will be compared. J is still pointing at the first character. So A and C will be compared. Are they two equal? No, they are not equal. So we'll increment only I because J is already in the beginning of the pattern. Okay, so after incrementing I, we reach to the end of the string, right? So the program here or the comparisons here will stop. Okay, and hence the result will be that we found the given pattern in the given string at one index, that is your 5. Okay, so this is your naive algorithm or the basic algorithm. If you want to implement it, this is how it works. Okay, now let me take you to the worst case analysis of the naive algorithm. Okay, where there will be maximum backtracking and maximum comparisons. Here, if you see, was there anywhere backtracking done? Yeah, J was always backtracked or decremented by some value, and similarly, I was also backtracked by some value. Right? Let's see here in the worst case how the backtracking actually worked. So the string is AB, 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 and ABC. Okay, the given pattern to be matched is ABC. Okay, so I'll quickly go ahead, just change the pen pointer color. So we'll match A. So J will be pointing here and I will be pointing here, right? Initially. So J and I will be matched. It's matching. So we'll increment. We'll increment this also. These two is matching. Yes, we'll increment this. We'll increment this also. These two are not matching. So you have to decrement now. So J will be decremented by 1, 2 places. So I will be decremented by how many? 1 place. 1 less than the J, right? So I will be decremented by 1 place. So I will be pointing out here. Now we'll compare I and J again. So J is pointing at A now and I is pointing right now at B. Okay. So B and A, this is equal? No, it's not. So we'll increment I. Okay. Now I is pointing to A, this A, and J is pointing to A. So is this two equal? Yeah, they two are equal. So we'll go ahead and point to next. So J will also be now incremented by 1. Now B and B, yeah, it both are same, right? So again, both will be incremented if they are same. So I will be incremented here. Now I and J will be compared. C and A is compared. So C and A are not equal, not same, right? So in that case, you have to decrement. How many places J will be decremented? It will come to the beginning of the pattern, right? So I will be decremented by how many? So J is decremented by 1, 2, right? So I will be decremented by 1 less than J, that is 2 minus 1, 1. So I will be decremented by 1. So now I is pointing over here. Let me erase the other parts. Okay, so right now J is pointing at the beginning of the pattern. Okay, and I is pointing at B. So I'll erase all these. So I hope this is clear now, neat. Okay, so J is pointing here. Now you see, I and J will be compared. It's not matching and J is already at the beginning. So only I will be incremented. Now I and J is matching. Yes, it is. If they are both same, then both will be incremented. Okay. Now J and I are again same, right? B and B. So both will be incremented. Now I and J, are they equal? No, they are not. So what will happen? J will be decremented by how many? 2 places. It will come in the beginning. So I will be decremented by how many? 1 less than J. 2 minus 1, 1 place. So I will be decremented to this location. That is, I will be pointing over here. Right? Now I is pointing here, J is pointing here. So these two will be compared. Are they two equal? No. So I will be incremented. This will remain there. Now I and J will be compared. So here these two are equal. So yeah, okay, I will be incremented and J will also be incremented because they are equal. So B is similar to B. Again, they are equal. So I will be incremented and J will also be incremented. But again, coming at the third place, we saw that the two characters are different. The two characters A and C are different, right? So what we have to do in case of different characters, we should decrement I and j. So j will be decremented by two places. J will be pointing now at the first character. So I will be decremented by how many? 1 less than j, that is 2 minus 1, 1. So I will be decremented at this location. So I is pointing right now here. Right? So now I will be compared with j. So j is pointing at A, I is pointing at B. So B and A are not equal and j is already in the beginning. So only I will be incremented. Now I is compared with j. So they both are equal. Okay, j will be incremented. I will also be incremented. Now I is pointing to B, j is pointing to B. Both are equal. So j will be incremented. I will also be incremented. I and j both are again equal. Both are having character C. Now this will also be incremented and this will also be incremented. So you can see here that as we reach to the end of the pattern, so it means this is the pattern found in the given string. Okay. And also we reach to the end of the string. So the program will stop here saying that only one pattern was found, or only one place at only one index the given pattern was found in the string. Fine. And that index was, if I count from here, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So at the ninth index, we found the given pattern in the string. So you could see, students, here that so many times we have to backtrack. Even J was backtracked so many times in the beginning of the pattern, and I was also backtracked so many times to some previous locations. Okay. So in this situation, in this worst case scenario, what happened was that the first two characters was matching every time, right? But the third character was not. And to check that, every character here was compared with all three, right? So for one given character, we had to do 3 comparisons, right? So this was a lot of backtracking done. And this is the worst case scenario for the naive algorithm to work. Another example, if I would give you, so suppose the string is A, B, and the given pattern is AB. Now you could see here, this is the worst case scenario. You have to compare for every character both of these, because every time the first character will be same. But finally you will find it at the end of the string, the given pattern. Right? So this was the worst case scenario for the naive algorithm. Now, with the help of this worst case scenario of naive algorithm, we'll be able to arrive at the time complexity of naive algorithm. Okay, so for a given string, the pattern had to be found in the given string, right? Suppose the number of characters in the string is, so here if I take the example 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 6, 7, 8, 9, 10, 11. So 11 characters are there, right, in the string, and in this 3 characters are there. So you could see here, this is also a worst case scenario. Like every time the first 2 characters will match, but the third character will not match. And at the end, it is going to match, right? So what you have to do is that for every character, you have to compare all the 3, because every time the first 2 will match and then you'll come at the end and then again go at the beginning. So for every character here, these 3 comparisons will be done. Right? So if there are 11 characters here, and for each character 3 comparisons has to be done, then for 11 characters, how many comparison will be done? 11 into 3, right? Now let me generalize this. Suppose in the given string we have n characters. Okay. In the given pattern we have m characters. Then the time complexity in the worst case scenario will be 11 into 3, that is n into m. N into m. So the time complexity is nm. Big O of nm. As we have done here the worst case analysis of the naive algorithm, it was easy to understand that how we can arrive at this O of n into m time complexity. So this was all about the basic algorithm or the fundamental algorithm, that is your naive algorithm. Let us talk about why KMP algorithm is needed. So why KMP algorithm? For that, you have to understand the drawback of the fundamental or the basic naive algorithm. So both the algorithms are used for pattern matching. There are many more algorithms that are used for pattern matching, but our comparison here is with the naive algorithm, the basic algorithm. So for that, first let us see what are the drawbacks of the naive algorithm. First drawback is it doesn't study the pattern. For example, if in a given string we have to find a pattern A, B, C, B, A, B. Okay, suppose this is a pattern to be found in the given string. So some kind of analysis should be done on the given pattern so that our process of finding out the pattern in the given string eases out. Okay, for example, if I try to analyze or study this pattern, you could see that the starting two characters and the last two characters are similar. So maybe with this analysis, we could ease our process of finding the pattern. But in basic naive algorithm, it's a complete brute force approach or a brute force method where no such study is done or research is done on the pattern to be found in the given string. Okay, it just starts with the process and ends till the end of the string. Right? So this is a drawback of naive algorithm. The most important drawback is that the complete backtracking of the string is required. For example, if suppose the given string is A, B, C, D, A, B, C, E, okay, and we have to find out the pattern given is A, B, C, E, suppose, okay. This is the worst case analysis again. So you have to find out A, B, C, E. So in this case, what you will do is you'll start from here, keep on tracking A, B, C, D, and at the last character is not matching, right? A, B, C, and then last character is D, and here it is E, right? So what you will do, you will again go to the beginning, like the character B, and from here you will start again the comparisons, right? So if there is no match between the characters of the pattern and the string, then you have to backtrack completely, right? Here you can see the half part of the pattern or more than half part of the pattern is matching to the string, but the last character was not matching. Because of this one last character, we have to trace it back to the beginning of the string again. Not completely in the beginning, but yeah, somewhere it has to be backtracked, right? We'll start again from the second index. So this backtracking is required of the string again and again. Both the pointers I and j, if suppose I is pointing to string and j is pointing to pattern, then both of these pointers have to be backtracked again and again in case of naive algorithm. So this is one of the very crucial drawback of naive algorithm, which leads us to the implementation or invention of various new algorithms used for pattern matching. Now, how to improve brute force technique, that is your naive algorithm, and come up with the KMP algorithm. So the only single point by which we can improve the naive algorithm and reach to the KMP algorithm is by studying the pattern. That is, if a pattern is given to be found in a string, and suppose the pattern is A, B, C, A, B, then we have to try to analyze or study how this pattern is, so that we don't have to do a lot of backtracking. Okay, for example, if we would analyze this pattern that the starting two characters A, B are similar to the last two characters. Okay, and if in the given string we found somewhere in the string the characters are in this way, okay, A, B, C, A, B, okay, then in that case, what will happen that the first two characters will be matched, first three characters will be matched, first four characters will be matched. Now the fifth character is not matching. So in place of coming or backtracking it to first or the second index, what we can do is, it has been matched till here, right? And only the last character was not matched. So let's not backtrack it to completely and just check for, or study the pattern in such a way and check for only those characters where the last one is also matching. Getting it? So some or other way we have to study the pattern. Another example could be that if suppose this is the example where you can see first and the last characters in the pattern are similar. Okay, so in the string which we are looking for, we'll try to find out such places where the first two were matching, only the last was not matching. So in that case, in place of going to the beginning, we can start from here because first one was already matching and the first and the last were repeating, right? So this kind of pattern study is important here, by which we can come up with a new algorithm, that is your KMP algorithm. Let us talk about KMP algorithm, knuth-morris-pratt algorithm. So knuth-morris-pratt algorithm, as the name of this algorithm is short formed into K, M and P, it is behind the two scientists or two people who has invented this algorithm, who gave an idea of this algorithm, that is your knuth-morris and Pratt. So these were the people who gave this algorithm, and the name of the algorithm, KMP algorithm, is behind their name itself. Now, KMP string matching algorithm. So KMP uses a degenerating method of string matching. What is the meaning of this degenerating method of pattern matching or string matching? It means that in the KMP algorithm, we have to first identify or try to study the pattern, the occurrence of the characters in the pattern. Okay, on the basis of the occurrence of characters in the pattern, the matching with the string will be done. Matching with the given string will be done. Okay, it identifies a repeating sub pattern. For example, if the given pattern is suppose A, B, C, A, B, then you can see this AB is repeating here again AB, right? So it studies, this KMP algorithm studies this repetitive pattern, and on the basis of this, then it goes ahead and looks in the given string that the pattern is being matched or not. Okay, so this is your KMP algorithm. It analyzes the pattern. It keeps track of the history of pattern. So it not just analyzes it, but also keeps a track that, okay, these two characters were again repeating here as the same two characters, right? So this will be stored somewhere in the history, and which will act as an input to the logic or the program of KMP algorithm. Okay. And here third point is that no backtracking is needed. Meaning we don't have to backtrack the characters of the string again and again as it is done in the naive algorithm or the basic brute force method algorithm. Okay, so backtracking is not done as we analyze the pattern and intelligently try to find out the given pattern in the given string. So backtracking will not be needed there. Now, let us first understand what are the components of KMP algorithm. Then we can move ahead and try to see how KMP algorithm works. Okay, but before that, if I talk about the components of KMP algorithm, the first one is definitely a given string. Okay, there will be a sequence of characters in the string or sequence of data or token, whatever. But here I'm taking example of characters. So this is the given string. Then there will be a pattern. So we have to search for this pattern in a given string. Okay, so there will be a pattern in a string. Next is your prefix, suffix, and common subsequence. Okay, now what is this? So if I ask what is prefix of any given word, those characters which are attached at the beginning of the word are called its prefix. And about suffix, those characters which are attached at the end of a given word are called as suffix, right? For example, if I take maybe the word here as cat, okay? So what will be the prefix for this? C is one prefix because C is at the beginning of this word. Another prefix would be CA, right? And then the another prefix would be CAT. Okay. If I talk about the suffix of this word, what are the characters at the end of this word? T, then AT, and then CAT is also at the end of the word. Now, this part we don't have to consider while talking about KMP algorithm. Okay. So we are talking about proper prefix and proper suffix only. Proper prefix is where we don't take the complete word as a prefix. Okay, or complete word as a suffix. So we are talking about prefix, but proper prefix basically where we are not taking this into count. Okay, so prefix for this word cat will be C and CA. For suffix will be T and AT. Okay, so you can see here if I ask about this given pattern A, B, C, D, A, B, C, that is A, B, C, D, A, B, C. If I ask the prefix of this, so it will be first only A, right? Then A, B, right? Then A, B and C, then A, B, C, D, then A, B, C, D, A, then A, B, C, D, A, B also, right? Okay, this is written twice. So A, B, C, D, A, B, right? as we are not taking the full word, complete characters of the word as a prefix, so we'll only take into account this much. Talking about suffix, so again the suffix will be whatever words are attached or whatever characters are attached at the end of the word. So C, B, C, right? A, B, and C, D, A, B, C, then C, D, A, B, C, right? Then B, C, D, A, B, C. Correct? So this is your prefix and suffix. Now, why I'm talking about prefix and suffix? Because using these two, we are going to analyze the given pattern. Okay. Now you have to find out the common subsequence. That is, what is common between this prefix and suffix? That becomes the common subsequence. Okay. Now, what is a common between the prefix and suffix? Which set of characters are same in prefix and in suffix? So you can see here, only ABC and ABC here are similar. Rest all are different, right? Yeah. So only one character or set of characters is there which is similar or same in both prefix and suffix, and that is your ABC. So we'll take into account ABC as a common subsequence. Okay. So this is your common subsequence. Now, how with the help of this common subsequence we are going to analyze the pattern. Okay. So let us see. So with the help of this common subsequence and prefix and suffix concept, directly I'll go to creation of LCS or a table. So this is basically a table, or you can say a prefix table. Okay. So this is TABLE, table or prefix table. Okay. Now how is this table constructed? Because this table is going to be used in applying a KMP algorithm. So it is very important to understand how this table is constructed. So let us go and understand this. So to construct the prefix table, it is constructed from the given pattern. Because this prefix table helps us understand or analyze the pattern. Okay. So I'll take this example itself. The pattern given here is A, B, C, D, A, B, and C. Okay. So to construct a table for this LCS table or a prefix table, whatever name you can call, both is correct. What we have to do is we have to construct the table with first entry as the characters of the pattern. Okay, D, A, B, and C. Programmatically, when we try to implement it, we can eliminate this part and just have this as the part of the table also. But here to understand, let us put it in this format. Okay. So first part of the table will be, or first row will be the characters of the pattern. Second row will have certain values, that is starting from 0 to n. Okay. Now what are these values? How is it filled? So you see here, we'll start from the first character. So this is A. Now, as we are starting from the very first character, there is nothing to be matched before this character, right? As this is the first character, so this will be always 0. Now we'll go to the next character, B. Is B matching with any of the previous characters in the pattern? No, there is only one previous character as of now, A, right? So it is not matching with that. So this will also be 0. Now, is C matching with any previous characters, that is A and B? No, right? So this will also be 0. Let's see D. D is matching with any of the previous characters in this pattern. C, B, and A? No, right? So this will also be 0. Coming to A. Now, is A matching with any of the previous characters? Yeah, it is matching with this A here, right? So what is the index of A? Okay, if I represent these index values from 1, so 1, 2, 3, 4, 5, 6, 7. Okay, so A is matching with this A, and index value for this A is 1. So it will be 1 here. Now, next character B. B is matching anywhere? Yeah, B is matching here. Okay, so B is matching with this B and its index value is 2. So this will be 2 here. Now C, is C matching anywhere before? So yes, C is matching with this location, right? And its index value is 3. So this will be 3. So this is how we'll construct the table, prefix table or LCS. Okay, another example I would take again here to make it clear. The pattern is AB, C, AB, ABC. Okay, this is the pattern, suppose. Okay, let us construct the LCS or the prefix table for this. So A, B, C, A, B, A, B, C, right? Okay. So this will be something like this, right? So we'll construct the values inside this prefix table soon. Let me draw these lines. Okay. Now we'll start from A. So as there is nothing to be matched or compared for this A before A, right? So this will be always 0. Now B, is it matching with any of the characters before the character B? No, right? Only one is there, A. So it's not matching. C, is it matching? No. B and A, nothing is matching. Is A matching with any of the previous characters? Yes, it is matching here. And what is the index of A? 1. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So A is matching with 1. Here A. B is matching with any of the characters. Is it matching? Yes, it is matching over here. Right? So what is the index of this B? 2. So it will be 2. Now this A. Is A matching with any of the characters before? So it will be compared with this. It's not matching. It will be compared with this. It is matching. What is the index of this? 4. So this will be 4 here. Okay, it will not go to the first one. It will start matching from this side and then go on this side. Okay, now B. B will be matched with A. It's not matching. B, yes, it is matching. So what is the index of B? 5. So 5 will be the value here. Okay, so C will be matched with all the previous characters, but starting from this location and going ahead. So C will be matched with B, not matching, A, not matching, B, not matching, A also not matching, coming to C. Yes, it is matching here. What is the index of C? 3. So 3 will be the value here. Okay, so this is how we construct a prefix table or LCS. Now let us see the example of KMP algorithm. So as I already explained what is LCS and what is prefix table. So that prefix table is going to act as an input to the KMP algorithm. So the given string is this one and this is the pattern. So first step would be to construct a table, the LCS, right? Or a prefix table. So to construct that, let us take the pattern. So A, B, C, D, A, B and C. Okay. So how to construct the table? Let us quickly create it here. That table will help to analyze the given characters in the pattern. Okay. So A will be marked 0, B will be also 0, C is not matching with any of the previous characters, so 0, D is also not matching, so 0. A is matching with the character here, so its index is 1. If I consider the index 1, 2, 3, 4, 5, 6 and 7, so A is at the index 1, so 1. B is matching anywhere with the previous characters, yes, over here, and its index is 2. C is matching anywhere, yes, over here, and its index is 3. Okay, so this is how we construct the prefix table or LCS. Right? Now the given string is A, B, C, D, A, B, C, A, B, C, D, A, B, C. Right? And the given pattern is A, B, C, D, A, B, C, which you have to find in the given string. Now, again, here also to implement KMP algorithm, we have to use two pointers. One is your pointer to point every character of a string, another pointer to point every character of the pattern. So let me change the pen color to make it a little clear here. So I and J, two pointers I'm going to use. So I will be pointing to the first character of a string and J will be pointing at 0th index. That is, first index is starting from the first character of the pattern, right? So J will be pointing one before that. Okay. This is just the starting point for the pointer in the pattern. Now, what you have to do is compare the element that is being pointed at ith location and J plus 1th location, because J equals to 0. At 0th index, there is nothing, right? So we have to compare with the first element of the pattern, first character of the pattern. So J plus 1th element will be compared with ith element. Okay. So in the string at J plus 1th element, you have to compare with pattern ith element. Okay. If they are equal, so here A and A are equal, right? So in that case, you have to increment I as well as you have to increment J. Fine. So if they are equal, then you have to increment I as well as increment J. Clear? Now again, J plus 1 will be compared with I. So I is B and J plus 1 is B. So they are equal again. So J will be incremented and I will also be incremented. Now J plus 1, that is C, will be compared with I, that is C. So they are equal again. So J will be again incremented to this location. And I will also be incremented. Now I and J plus 1. J plus 1 is D. And I is also D. So yeah, they both are same. So again, both will be incremented. So I will also be pointing to A. Now j plus 1, that is A, and I is also A. So both of them are again matching. So both will be incremented. Both the pointers I and j will be incremented. Okay. Now j plus 1 is B and I is A here. Okay. So I is A and j plus 1 is B. So they two are not matching. Okay. So if these two are not matching, then in that case, what has to be done? We have to decrement. So point here is if s of j plus 1 is not matching with pattern of, okay, sorry, this was pattern of j plus 1 and s of I, and this will also be, okay, I'll erase this and write it afresh. Okay, this, fine. So this is a pattern of j plus 1 and string of I, and this is also pattern of j plus 1 and string of I. Okay. So if it is not equal, then you have to decrement j. Now where to decrement j, that you have to understand. So j is right now pointing at this location, right? J plus 1. We have compared this with I. So j we have to decrement at this particular index. Okay. So j is right now here pointing at index 1. So it will be decremented to index 1. So j will be now pointing over here. It will be decremented from here to here. That is index 1. Okay. We don't have to do anything with I. I will be there itself. Now you have to compare again. J is pointing at this A, right? And this is also A. So yes, these two are equal. So what we'll do in case of equal, we'll increment both. I will be incremented. J will also be incremented. Okay. Now I and j are also equal again here, right? So j will be incremented to this and I will also be incremented to this. Now j and I is equal again here. So both will be incremented, right? So j will be incremented and I will also be incremented. So now j has to be decremented. Where will j be decremented? So j will be decremented at the index which is being pointed by j right now. Okay. And that is your first index. Okay. So it will be pointing to first index now. So j will be over here. Okay. I will be at the same location. No more decrement or backtracking for I. Okay. Now again comparison will be done. So comparison will be done. J plus 1 will be compared with I. Right. So j plus 1 is B and I is A itself. So again there is mismatch. Right. So I, we don't have to do anything. J will be decremented. Now j will be decremented where? At this location. Wherever currently j was pointing, that index or that number in the table, it will be decremented. So j will be now decremented to 0th. Now 0th is nothing but one index before even the starting index of the pattern. That is j equal to 0 here. So j will be now pointing at this location again. Okay, I'll erase the other things so that it is little clear here. So we have to start from again the beginning. Okay, so this also I'll remove. So currently j is pointing in the beginning of it. Okay. Okay, this will be like this. Now, again you have to compare this I with j plus 1. So j plus 1 is pointing at this place and I. They both are equal, right? So we'll increment I as well as we'll increment j. So j will be now pointing over here, right? Now j plus 1, that is B, will be compared with I. So j plus 1 B and this B is same, right? So this both will be incremented. This will also be incremented. Now j plus 1, that is C, is equal to I, that is C, right? So again the both will be incremented, both the pointers. So I and j plus 1 is D here, okay? And I is pointing to A. So they are not equal, they are not same, right? So we have to decrement what? J. And where we should decrement j? Wherever it is pointing right now. So currently the value in the table is 0 for j, right? So it will be again pointing at j equal to 0. That is, it will come in the beginning again. Okay. And you have to restart from the beginning again. Getting it? And I is still pointing there itself. Okay. So now you have to compare again. J plus 1, that is A, will be compared with I. So yeah, it is same, right? So I will be incremented. Now you'll compare j plus 1, that is B, with I. So yeah, it is same. So we'll increment both. Now j is pointing at this place right now. So j plus 1, that is c, is equal to I, right? So yeah, both are same. So we'll increment I as well as we'll increment j. So j is right now pointing at c. So j plus 1, that is d, is equal to I. Yes, it is equal. So we'll increment both, right? So j plus 1 is a, which is equal to I, right? I is also pointing to a. So yes, both will be incremented again in this case. Now j plus 1, that is b, is pointing to I, that is b itself. So both will be incremented again. Now j plus 1 is c, right? And it is equal to I, that is c again. So this will be incremented, but this will reach to the end of the pattern. And if this is incremented, I mean, this also has checked till here. And if it tries to check, like j is incremented, right? And if it tries to check further, like j plus 1 with I, it has reached to the end of the pattern as well, right? So it means that the pattern given is found in the given string, okay? And at what index? So to find out that, we have to go that many positions behind where j is currently in the index, okay? So j was here currently in the index as 7, right? So from here 7 places back, that is over here. So this is the starting index for the given pattern in the string, okay? So this is how KMP algorithm works. That is, you don't have to backtrack I, you just have to backtrack or decrement the jth pointer, or backtrack only in the pattern. And how you have to backtrack also, that is dependent on this table. Wherever currently the j is pointing, that location you have to push back j and start comparison from there itself. Okay, so this is how your KMP algorithm works. Let us see now KMP search algorithm code building with examples. So to talk in KMP search algorithm code building with examples, I am going to talk here the algorithm of KMP pattern search, okay, or pattern matching. So here the algorithm is something like this. It starts from creating a prefix table. Okay, to create a prefix table, we should be aware of the number of characters in the pattern, right? So that has to be calculated. That is your pattern length, and pattern length, the pattern, and the table, maybe the empty table initially, which will be also the output of this prefix function here. So prefix table will be the table that will contain the repetition or the analysis over the given pattern, right? So this is the function over here which will construct that prefix table and give us as the output. After once that is done, that will act as the input to the main loop of the algorithm, okay? And the guiding condition will be that while I is less than n. Now what is I here? So I is that pointer which we will be iterating over the string, right? And the pointer should go till where? Till the end of the string. So for that we need to know the length of the string. So that will also be calculated and stored in n. Okay, so from the first character to the last, from I equal to 1 to n, it should go on, the complete loop should go on. So there what you have to do, you have to compare these two, right? If they are matching, then you have to increment both I and j by 1, okay? And if the you reach to the end of the pattern, then just print the index I minus j, which will be the starting index for the given pattern. If you reach to the end of the end of the pattern, that is your m. Okay, m is what? Pattern length, right? So if you reach there, it means the pattern is found. And then you have to print the index there. Now the else condition is that if this pattern is not matching, then in that case what has to be done? So if a pattern is not matching and I is less than n and you have not reached to the end of the string, still there are characters in the string, then you have to decrement j only, right? And if to decrement j where? So j will be decremented 1 less than where j was pointing. So this algorithm is in the condition that I pointer, suppose this is the pattern, okay? Pattern is ABC and the string given is A, B, C, D, E, F, okay? So pattern will be, the table will be constructed out of this pattern, right? And j is pointing right now in the first place. And here I is pointing right now at the first place, okay? Or you can take another example also, or another way of solving it also, where j will be pointing at some 0th location before this. So this algorithm is considering that j is pointing over here. So in case of decrementing it, you have to consider j minus 1th location in the table, okay, to decrement j. Else you have to increase I by 1. If j is not pointing at 0, then this has to be done. If j is already in 0, then you don't have, j cannot be decremented further anywhere. So in that case, you have to just increment I by 1. Okay. So this is how the algorithm for KMP search or KMP pattern matching works. Let us see this with the help of an example. So here, suppose the given string is AB, AB, ABC. Okay. And the pattern which I am finding it is AB. Okay. Now I'll construct okay, let it be. Now I'll construct the table first. The prefix table has to be constructed. So A and B. Okay. This will be the table. This will also be 0. This will also be 0 because there is no repeated characters in this. So it's going to be 0 and 0. This is how table will look like. In the next step, we have to perform this, right? Till we reach to the end of the string. So it's to start I from here and reach to the end of the string. Okay. And j will be starting from the beginning, that is 1. So j will be starting from here and we have to keep on comparing. Okay. Now let me change the color here again, the pen. So the things will start from here, right? The algorithm will start here. String I is equal to pattern j. So I and j will be compared. It is matching, right? If it is matching, then you have to increment I and j both by 1. So I will be pointing here, j will be pointing here. It is matching again here also, right? So in that case, what you have to do? So it's matching. So it will increment I and it will increment j. Now j will be incremented where? Because the pattern ends here. The pattern is of only 2 characters, A and B. So this condition is that one. So if j reach to the end of the pattern, then you have to print this index I minus j. So j will be pointing now at table j minus 1. So j minus 1, that is at this location. And j will be pointing at this location now. That is your first location. That is here. Okay. And the index will be I minus j, right? So I was pointing at this location, right? The increment was happened later on, right? So I is pointing here, that is at location 1. If I start from 0, 0 and 1, right? And j is currently pointing at 1. So j is also pointing at 1. So 1 minus 1, that is your 0. So the starting index for the pattern that was found is 0th index. That is your this place, right? And this will be displayed as the output. Now we'll move ahead again as you have not reached to the end of the pattern. So while loop is still not, it's still being satisfied. So we'll move ahead. Right now I is pointing over here. Okay. And j is pointing at the beginning, that is over here. So I and j will be compared. Again, I and j are equal, right? So I will be incremented as well as j will be incremented. J is pointing at this B, I is pointing at this B. So I and j are again equal. So before incrementing I and j, we'll see that j has reached to the end of the pattern, right? It means what? That here I will be incremented, but the pattern was also found and the index will be displayed. So what will be the index value? I minus j, right? And I is pointing here 0, 1, 2, 3. So 3 and j is pointing at 1. So 1. So 3 minus 1 was 2. So 0, 1, 2. This was the starting index for the next pattern or the place where pattern was found, right? And now j will be pointing at table j minus 1. So table of j minus 1. J minus 1 is this location. This is 0th location. So j will be pointing at the 0th location, that is at the beginning, that is first character, right? So I'll erase the other things here to make it little clear. So right now the point is that j is pointing at the very first location. Okay. So this is how it is. J is right now pointing over here and I is pointing over here. Now I and j will be compared again. So you can see it is matching. I will be incremented. J will also be incremented. Now I and j is matching here also. So I will be incremented and j as j reach to the end of the, the pattern. So again, this condition is satisfied and this loop will be executed. Okay. So to execute that loop, j will be now pointing at table j minus 1. So table j minus 1 is this location. So j will be pointing at 0th location again. Okay. And we have to print the index I minus j. So right now I was pointing where? At this location, right? So this was location 0, 1, 2, 3, 4, 5, right? So 5 minus j was pointing at 1. So it was fourth location, fourth index. So 0, 1, 2, 3, 4. So this was the index location of the pattern found, right? Now I is pointing over here. Still I is not reached to the end. Still one character is left. So j equals to a and I is equal to c here. So I and j will be compared. They are not equal. So in case of not equal, this will be the else loop which will be executed, right? So if it is not equal and I has still not reached to the end of the pattern, then in that case you have to come here and compare again. If j is not equal to 0, but here j is equal to 0, then in that case you have to just simply increase I by 1. So you'll increase I by 1 and you will reach to the end of the string. Hence this you'll come out of this while loop and the algorithm will stop. And this 3 will be the output of the code. So this is how I have traced the algorithm. The same thing you can convert it into the program, maybe the Python code or Java code, and you can write the implementation for this KMP algorithm. Now we will see the KMP algorithm implementation in Python. So I'll be using Google Colab to write down the code in Python. So let us go to the Google Colab and start typing the code. So I'll create a new code line here. Okay, so let's give a name here, KMP. Okay. So now here I'm going to first define a method. So two methods I'm going to write. One method will be to perform KMP algorithm and the other method will be to create a prefix table. Okay. So first I'm going to write the method for KMP algorithm. So to write method, def is a keyword used, and let me give the name of it to be KMP itself. It will take two parameters, pattern and the string, right? Okay. So now first we should know the length of the string and length of the pattern. So length of the string. Okay. And then length of the pattern. I'll store it into two variables. Length of pattern. Okay. Now we have to create, we need a table here, right? That a prefix table. So for that we'll write a different method. But as of now, I'm just assuming that that is result of that method is stored in this variable table. Okay. So suppose the function name I'm going to give as prefix, and it will take two inputs, pattern and the length of the pattern. Okay. Now let's get started with the main part of the algorithm. But before that, we need two variables to be initialized to iterate over the string, two pointers basically to iterate over the string and the pattern, that is the table. So m and n is what I'm going to take here, and n also let me initialize to 0, and then also for index we'll take okay, it will be initially empty. 1 second. Yeah. Now the while loop will start. So we have to keep on iterating until we reach to the end of the string, right? So until m is not equal to length of the string, we have to keep on performing the operations. And that operation is that you have to compare if string n, not m, okay, is equal to pattern n. Then what has to be done? Then in that case, m will be incremented by 1 and n will also be incremented by 1. So, okay, I was not meant to execute this. Let's not concentrate on it. I was doing backspace actually. So else, what has to be done? So in that case, we have to have the table. We have to decrement the jth pointer, that is your n. So here where to decrement, that will be decided by the table, right? So this will be the decrement part for j, that is n, and then you have to also calculate the index or take the index into count. So there, okay, let first take the index into count itself, that is table n minus 1. And now if one more condition, n is equal to length of the pointer, like we reach to the end of the pattern, LP, that is length of the pattern, we reach to the end of it, then in that case we have to, in this index, we have to append j minus I, right? That is m minus n. Okay, and n will be, that is j pointer will be decremented to where? Pointing the index and in table at n minus 1. That is j minus 1, right? So this is done. Okay, this will not be round bracket. This should be this one. And this will also be a square bracket. This is done. Now, else, again one more condition. So else if, let's have, so elif n is equal to 0. That is, we reached the end of the string. Then in that case, m will be equal to m plus 1. And we have to simply return, after the method completes, you have to return the index. Okay, so this is completed. Fine. Now let's write the method. Okay, it again executed. Fine. Now let's write the other method, that is your method name was prefix. Okay, so we'll write prefix, define prefix. It will take two parameters, that is your pattern and length of the pattern, right? Okay, to write this, what we have to do in this is that you have to first initialize the table. So all zeros, I'm going to initialize it. Okay, then next is initialize n and m also. So n I'll initialize to 0 and m I'll initialize to 1. Okay, moving ahead, while loop to scan through the pointer, through the pattern, m not equal to length of pointer. While this is not there, what we should do, if pattern m is equal to pattern n, then n is equal to n plus 1 and table at m we should fill n. Okay, so this is done. Table m equals to n. Okay, now next what we have to do is we'll increment m also. So m will be equal to m plus 1. Now we'll go to else if condition. So elif n is not equal to 0. Then in that case, what has to be done is that n will be equal to table n minus 1, right? Okay, then else, just go to else loop. Okay, this will not be here. Yeah, so else table m will be equal to 0 and m will be equal to m plus 1. And then finally you have to return table. Okay, so this method is also written. Now let us write, okay, two methods are done. Now let us define the variables, initialize the variables and call the methods. So a, b, b, c. Okay, suppose this is a string and pattern is equal to ABC. Okay. And then to call the algorithm, which will be returned, index is the thing returned, right? So selected index will be equal to KMP, and we have to pass the pattern and the string. So pattern and a string. Okay. Fine. Now to print for I in a selected index. Okay. For I in selected index, what you have to do? Print selected. Okay. Pattern found at index. Pattern found at index, and then comma I. Okay. So all the indexes will be printed. So let's run the code and see if there is any error or it's working fine. Okay. Prefix. The name is correct. Prefix. Okay, is it returning table? 1 second. Okay, so fix this. Let's see. It says the error is here. Is not defined. Okay, but it is defined. Okay, yeah. So let's do this backspace. Yeah, so this will also be your backspace. And now it should work fine. Let's execute the code. It says index append. Okay, this will be round bracket, not square brackets. Sorry. Yeah. So let us run the code and check again. Yeah, so index pattern found at index 4 is the output. Let me just enhance the font size for you. So you can see here the pattern was found ABC. So ABC was found from here, right? This is the matching pattern. So 0, 1, 2, 3, 4. 4 is the correct index. So yeah, the answer, the output is fine. So this is your code for or implementation of KMP algorithm in Python. Now I'll talk about the time and space complexity analysis. So time and space complexity analysis of KMP algorithm. So first I'll talk about time complexity. Okay. The time complexity of KMP algorithm is big O of m plus n, where the length of the string is suppose m and length of the pattern is suppose n. Then the time taken is m plus n. Why it is m plus n? To understand that, let us understand in this way. Suppose this was the string and this was the pattern. Okay. So in that case, we never used to backtrack the string, right? If I pointer started from here, it goes on and goes on, right? So we have to trace the characters of the string only once. So if there are n characters here, we have to trace it m times, right? And for pattern, to construct the table, right, the prefix table, we have to scan each character of the pattern once, right? So if there are n number of characters here, so time taken to create this prefix table will be n. Now combining these two, it will be n plus m. So big O of n plus m is the time complexity for KMP algorithm. Talking about the space complexity of KMP algorithm. So as the string doesn't take any space, doesn't require any memory to be stored, one by one we can fetch the characters of the string and keep on comparing, and the algorithm can run. But for pattern, we construct a prefix table, right? Prefix table. And this prefix table has to be stored somewhere in the memory because it is required as an input to the KMP algorithm for pattern matching. So whatever is the length of this pattern, that much space this prefix table will take, right? So the space taken by the prefix table will be n, if suppose n is the number of characters in pattern. Or I can say if the length of pattern is n, then the table will take n space to be stored. Okay, and the string will not take any space. At the runtime itself, one character can be fetched and it can be executed. So the space complexity for KMP algorithm is big O of n. Talking about the application of KMP algorithm. So application of KMP algorithm is generally for the longest string pattern matching. So wherever the length of the string is really long or large, there if you require to do pattern matching, then using naive algorithm or the basic algorithm may take a lot of time. Hence, KMP algorithm is an improvised version for pattern matching, and it takes less time to uh, perform pattern matching on longest strings. So the application of KMP algorithms are mostly confined to the areas where there is pattern matching to be performed on longest strings. One of the example is your DNA pattern matching. So in DNA, there are 4 characters, right? So those 4 characters pattern matching, if it has to be done for DNA, then the KMP algorithm is generally used. Now let's summarize the session. So in this video, I discussed about KMP algorithm confined to the pattern matching domain. First, we discussed what is pattern matching with an example, and then talked about the very basic pattern matching algorithm, that is your naive algorithm. What is the disadvantage and limitation of naive algorithm was discussed, and then how KMP algorithm improvise this naive algorithm by studying the occurrence of characters in the given pattern. So we studied that KMP algorithm, and also with the help of examples, we try to understand how KMP algorithm is implemented. Going forward, we discuss the implementation of KMP algorithm in Python. And lastly, after discussing the time and space complexity for KMP algorithm, we discuss the application areas as well for the KMP algorithm. So I hope you like the session. Thank you.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.